I believe we had something like maybe exercise number 11. 11, thank you. Thank you for confirming. So we're going to recall that if you break
Boarding in progress.
your angle, which is bigger than 360 degrees, with 360 plus a little extra. And a little extra is exactly 45. In other words, instead of sine of this 405 degrees, all I can do is consider sine of 45 degrees because that 360 makes no difference. The reason it makes no difference is because when you look at the circle with radius 1 and get this 45 degrees angle, then it'd be exactly the same as if you had rotation by 360, full rotation, and then by 45, just like we have here. So the value of sine as well as cosine will be exactly the same for 45 as for 405. So then you can take a look at a little circle diagram. I prepared this already. And for the angle 45 degrees, that has on the unit circle both and sine and cosine that are the same in measure, I can see that value of y coordinate, which is our cosine, is equal to square root of 2 divided by 2, right? So that's why I write the answer, radical 2 over 2, and that's it. Some people put 1 over square root of 2. Well, it's fine with me. I don't pick on that. Or some people actually use the calculator to do this problem and gave me a decimal instead of square root 2 over 2. Well, again, I still gave full credit for that. But I guess it's good that you be able to eventually start using that unit circle in the future, because there'll be lots of things in this class associated with that unit circle. That's why it's good that you will start to little by little get used to this. So I'm gonna try to see what else is interested in here. And I guess I just going to take a look at another exercise for a change with maybe secant. So exercise number 75, where we have secant of negative pi over 6. And I know that's 1 over cosine, isn't it? Of negative pi over 6. So this is analogous exercise. I just need to take a look at the negative angle of pi over 6. And what I'm going to do is, again, return back to that new favorite picture and locate where negative pi over 6 could possibly be. And it is right here, because you can see that if you rotate by negative, you go clockwise. Or if you rotate by 11 pi over 6, it'd be exact same thing. So if you want to know cosine, which is the first coordinate, right? That's a cosine of negative pi over 6, then it'd be square root 3 over 2. So let me return back to this textbook and write this as a square root 3 over 2. But it's going to be in denominator because in numerator I still have number 1. And what I need is just to flip that fraction. So I'm going to have 2 on the top and square root 3 on the bottom, because we can just, instead of dividing, get our expression flipped so it'd be multiplied. So how did I locate that? So it looks like if I see something with a negative in front, then I have to go clockwise direction. So we can take another look at this. I'm just gonna clean all that. So angle positive pi over 6 will be our favorite 30 degrees here, right? And negative pi over 6 is, excuse me, looks like I got some kind of cold. Very annoying. So positive pi over 6 and negative pi over 6. So we just go the opposite direction, right? We go so-called clockwise. So this way, I guess we have the point on the unit circle that we just take the first coordinate, which is cosine, right? That's a very good question, and that's really worth over weekend to look closer at this little circular diagram. And I think that if you try to redo the same exact exercises again, I hope you will start to feel better, because I know it's legitimate, very good questions, and it just needs a little bit time that you spend whenever you have it. That's the idea. So I guess I'm going to move on, and this section is pretty much over anyways. So I'd like to introduce you with one very important graph for our class, which is called graph of function sine of x. So it turns out the graph of that function sine has its own specific. First of all, it's in between of 0 and 2 pi. And then it extends to the left and to the right infinitely many times. Also, on the top and the bottom, it's in between negative and positive 1. So it's bounded by plus and minus 1. So that's what they actually trying to, I guess, justify when they give you this picture about. They just calculate a few points, and that's how they usually justify things. So they just calculate a few points and then they connect them, and that's exactly what they did to convince on figure 44, convince you that it is indeed the graph. And the graph of function sine is one of so-called library functions, which means that you just need to remember its shape or write it down someplace, because that way, I guess, you can always refresh your memories, find it, right? So that's the one that you should be familiar with. That's the point. I'm sure you saw other library functions, such as a parabola x squared, right? Or a cubic parabola in the previous math classes. So function sine is also analogous. And today I'd like to graph a few of these sine functions. I just want to look at function sine today. I don't want to go to the other functions, because I know if you know how to graph function sine, then you can graph cosine, you can graph the others. So our goal is, without a hurry, start to get used to these trigonometric graphs. So I'm trying to get to the end, to the exercises. It's not loading pretty quickly, I guess, but I hope now it will. So that's my advice, is to download the textbook to your device, because if you open it from your own device, it's not going to ever give you this slower times to get this graphs or move to the next page. So anyways, I'd like to produce a few graphs in here, and they actually discussing that, I believe, here in the next group of exercises. And I'll just take function sine. Next time I'll deal with function cosine. So how about exercise number 37, which talks about y is equal to -4 sine of x. So first of all, I noticed that since we have negative in front of our function, then the graph is going to be flipped. So it's going to go somehow like that. So it starts at 0, and then this, people say, main wave of the function will be starting going down rather than up when we had sine with a positive in front. Also, since it's multiplied by 4, turns out this so-called amplitude will be in between of minus and plus 4. So if you have just one sine, as the original function was, your amplitude, that's how they call these numbers, will be 1. But if it's 4 times sine, then the amplitude will be 4. So this is, I guess, thing to keep in mind, the amplitude. And I guess that's pretty much all it is, because I just graphed it. And of course, they like to extend this a little bit. It doesn't end definitely at the origin. It just keeps going and so forth. So idea of amplitude is here for us. How about number 40 exercise that says, try to graph sine of 3x. So sine of 3x is here. I need to think of my function sine, which is going to be, maybe I'll get to another page. I don't want to try to fit it in this little room. So I just need to go with this sine function. And this will be already well-known, this wiggle. So it turns out that this is so-called main wave. And now if you want to extend it a little bit, then you extend it a little bit. That's good enough. Yes, I'm gonna do one more exercise and let you go, because I have a real hard time to talk today. But anyways, let us see what's next. What changes if we have 3x here instead of x? And it turns out the standard way to take care of this is to bound it in between 0 and 2 pi. because that's how we produce that main wave, so-called, right? It's in between 0 and 2 pi. But it's 3x. So I have to divide by 3, and that way, when I divide by 3, my number 0, it's still going to be 0. And when I divide by 3x, it'll be 1x. And well, that's why I'm actually doing it, to pull out x, because we are graphing things on x-axis, not on 3x axis. So our main wave of function sine is now in between 0 and 2 pi over 3. So people say it's got squeezed 3 times. Okay, so that's really all it is. So interesting, right? Let me try one more, and as I said, I'm going to let you enjoy your weekend. It's Thursday, so you definitely deserve that. So I also told that I will be working on placing recordings of our lectures on YouTube, because I have this little channel where I have statistics lectures of mine, and I think it will never hurt that if I put trigonometry lectures as well. So I will, over weekend, put everything we had so far, and I'll create a special trigonometry folder, so everything will be in one place, because I know sometimes it's difficult to find this in those emails, and you might even delete it by accident. Well, if you by accident delete this recording, you still can check the deleted mailbox, so it's still there. Anyways, let me do number 43. So that's a case where you have 2 in front, so that's your amplitude, and a sine of 1/2 x in the parentheses. So let me get my favorite wave for sine. There's nothing negative, so I just take this main wave. But I already know that amplitude has to be 2, because, well, number 2 is multiplied by function sine. It's standard. Now, what happened with 2 pi? Well, I need to take so-called argument of function sine and post it in between 0 and 2 pi. And the argument is 1/2 multiplied by x. And when I post it in between 0 and 2 pi, then I have to double each piece of my little inequality, so that x will be isolated in the middle. So we get a 0 on the left side, and on the other side will be 4 pi. Okay, whatever it is, that'd be my piece, the ending point of that main piece. And then I just continue a little bit to the left and to the right. So we're going to graph these functions, sine and its friend cosine, and other 4 trig functions, and then we'll see graph of more of trig functions called inverse trig functions. So we're going to deal with all that. It's just a little introduction, so I think that it's a good idea that you start to think about this and maybe redo the same problems I did over weekend. I'm not giving you a quiz today. I'll just let you go and have fun. And next Tuesday, we're going to talk about cosine. So we're going to graph some more problems here, because I know there's more various little things that you can find in this section, and we will. So far, just a little start. So I'm going to, I guess, stop this recording and let you go today without a quiz. And